Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and these two particular questions belong to paper 9709/45 for the session May June 25. Let's start with the question number 3. It says a train travels 4.8 kilometer between two stations A and B. The train starts from rest at A and accelerates at a constant rate until it reaches a speed of 30 meters per second. It then travels at this constant speed for t seconds before decelerating at a constant rate, coming to rest at B. The total time for the journey is 180 seconds. Find the value of t and hence find the distance moved by the train while traveling at the constant speed of 30 meter per second. Well, it's a very easy and simple question. We don't have any difficulty to solve this. So before solving the question, before finding the total distance, we are going to draw a velocity time graph. If we can easily draw the velocity time graph, then solution becomes much easier. So let us draw the velocity time graph. This is the velocity, that means vertical axis velocity. After that, this is velocity, and we are supposing this horizontal axis as time, t second, and vertical axis is v meter per second, v meter per second. Okay, let me write this s over here. Okay. Sorry. Then it started from the first station, means A, from rest. And first phase, there are three phases. In the first phase, the acceleration was constant. So this is the acceleration for the first phase. Then the train was traveling at a constant speed. That means just parallel to the horizontal line. After that, it reaches the, look at this, coming to rest at B. At B, it was at rest and it was moving at a constant rate of deceleration. So, which one is our T? Actually, they have told us to find constant. Look at this. It first up to 30 meter per second. So, here it is 30. Let us write here 30. Okay. So velocity is 30 when it was accelerating at a constant rate. Then this is our t. That is the time when the train was traveling or moving at a constant speed. And the total time taken by the journey is 180 seconds. This is 180. Okay. Now, first of all, we should know that what is this T standing for. Well, so we know. Let me erase this portion which is unnecessary because there is no negative velocity. Well, so total distance. We have a clue that total distance S is equal to total distance. Can I use a different ink? So total distance is given, total distance. How much is the total distance given? Total distance is given, look at this, 4.8 kilometer. That means 4800 meters. Well, and we know total distance is equal to what? The area traveled by the train. That means this whole of this area is area of this trapezium shape. This is starting from 0 until 180. So it is a trapezium, and what is the formula for a trapezium? we know the formula for a trapezium is half of, let us write, half of the sum of the parallel sides. From here until this one is one of the parallel sides, which is t, length of which is t, and the other parallel sides is this, which is 180. So t plus 180 is the sum of the parallel sides into the height. How much is the height? This is height. Okay, this is the height between the parallel lines. Okay, so how much is the height? Height is 30 meters, means velocity was 30, maximum velocity was 30 meter per second, then equal to 4800. Well, now if we dissolve 30 by half, it is going to be 15. So 15 into t plus 180. T plus 180 is equal to 4800. After that, if we divide 4800 by 15, it is going to be t plus 180 on the left side, and it is going to be 15 3. Okay, 15 threes are 45, so 30 15 2, that means 320. It is 320, hence our t is going to be, t is equal to, from 320 if we subtract 180, it is going to be 140. So the value of t is 140. That means the train was traveling at a constant speed for 140 seconds. So this is one of the answers we can show. Okay, then the next part is they have told and find the distance traveled by the train while traveling at the constant speed. That means we will have to find the distance between these two straight lines. That means this distance is to be, this area is to be found. Okay, so for distance we know a formula, Shubert formula. What is the formula? I think you remember that formula is s equal to ut plus half at square. Okay, so distance s is equal to, we can write here, distance, no, not with this ink, let me change the ink. So distance s is equal to, distance s equal to, sorry, distance s equal to, ut plus half at square. Okay, now our u initial velocity, look at this. If we talk about this place, this portion, for this portion initial velocity was what? Surely 30. So 30, and time. How long was the time? We have already obtained that the time is 140 seconds. Okay, so into 140 plus half of acceleration. Look at this, as the train was at this phase, look at this, at the second phase there are total three phases. The first, in the first phase, the train was accelerating, raising its speed until 30 meter per second. Then it was moving at a constant speed. So when there is a constant speed, then there is no acceleration at all, so it is going to be 0. Well, now it is not 40, it is 140, sorry, it is 140. So finally we are going to get 3 14s are 42, isn't it? 42 and 2 zeros. So that is what the total distance, when the distance traveled by the train when it was moving at a constant speed of 30 meter per second. So this is the second or final answer to this question, and I think you have understood this very easily because there is no twist or complication in this question. So let's move on to the next question. And here, please don't get confused with this, that distance s equal to ut plus half at square. Here actually it is about the time when it was traveling at a constant speed. That means already we have found the time, length of the time it was moving at a constant speed was 140 seconds. So we have applied simple Schubert formula, s equal to ut plus half at square, and as it is moving at a constant speed, there should be no acceleration at all, so a is 0. That's why it is simply s equal to u into t, which is 30 into 1. 30 is initial velocity, final velocity is also 30, then into time is 140. That means 4200 meters have been traveled by the train. Let's move on to the question number 4. The next question is on the next page. So this question says, well, coplanar forces of magnitude 17 Newton, 51 Newton and 34 Newton act at a point O in the directions shown in the diagram, where tan alpha is equal to 15 over 8. Find the magnitude and direction of the resultant of the three forces. It carries 6 marks, so it should be a little bit longer. So first of all, before moving on to the solution, let us complete the diagram. Okay, if we complete the diagram, it will look like this. This is horizontal axis, this is horizontal axis. Okay, then this is the triangle, one triangle, this is one triangle, and that is another triangle. After that, this one is the third triangle. So as there are three resultant three forces acting on the particle, so there will be three forces. Let us erase these unnecessary parts. Well, we have already completed the diagram. Then there is one more information given here, which is tan alpha is 15 over 8. So if it is a triangle, angle is alpha, this is alpha, and tan alpha is, we know, opponent over adjacent. Opponent is 15 and adjacent is 8. Now we require hypotenuse. How can we find hypotenuse? We know that hypotenuse is equal to, hypotenuse is equal to what? Square root over opponent square plus opponent square plus adjacent square. Adjacent is 8 square. So 15 square means 225 plus 64, 279, I mean 289. So 289 is the square root of 289 is 17. So our hypotenuse is 17. This is 17. Well, so our sine alpha is going to be sine alpha, because if we resolve the forces vertically and horizontally, we must use sine and cosine alpha. Sine alpha is equal to what? Sine is opponent over hypotenuse. So 15 over 15 over 15 over, let me erase this. Okay, 15 over hypotenuse is 17. Then cos alpha is equal to, cos alpha is going to be adjacent over hypotenuse. Hypotenuse is 17, so adjacent is 8. 8 over 17. Okay, we have got both the sine and cosine values. Now we will have to resolve the forces. First, let us resolve the forces horizontally. So resolving forces horizontally. if we resolve the forces horizontally, then let us write. How will we write? We will write first. Yes, this can be shown. Let me show a little more. Well, so it is horizontal direction can be shown here. So x is equal to resultant force in x direction. So for the first triangle, it is 51 cosine alpha. For horizontal force, we use cosine angle, cosine alpha. Then plus the second triangle. For second triangle, it is 34 cosine alpha. 34 cosine alpha. Then this is our center. Okay, so from this center, as this is negative direction, this is negative direction, so we will have to subtract this. If we subtract, it is going to be 17 is the magnitude 17. Now we will have to find this angle. How much is this angle? Total is, look at this, total is 180. We are talking about only this portion. So this angle is going to be from 180, the middle portion is 90. So 90 goes away and alpha goes away. So this is 90, 17 cos angle is 90 minus alpha. That means 180 minus 90 minus alpha. So it is 90 minus alpha. Well, after that, equal to, now we are going to substitute the values already we have obtained. Cos alpha is 8 over 17. 8 over, I think before writing this we will have to expand one more line, because you are going to know why I am not applying the values over here. 51 plus 34, it is 85. 85 cos alpha minus, now look at this, cos 90 minus alpha is actually sine alpha. You know, this is not a new topic to be learned. In this case, we know that cosine 90 minus alpha is sine alpha, angle of sine. So it is going to be 17 sine alpha, 17 sine alpha. Now we can easily apply the values. Let us do so. Or 85 into cos alpha is equal to, we have obtained 15 over 17. 15 over 17 minus 17 into sin alpha is 8 over 17. 8 over 17. So finally our resultant force in x direction is what? It is going to be 17, 5, 5, 15, 75. And from 75, if we subtract this, sorry, we made a mistake. Cos alpha is not 15 over 17. Cos alpha is 8 over 17. So it is going to be 8 actually, and it is going to be 15. So 8 over 17 and 15 over 17. So what is it going to be? 17 5s are 85, 5 8s are 40. So 40 minus 15 is 25 Newton. So horizontal force, resultant force is 25 Newton. Well, now we are going to resolve the forces vertically. So let us write resolving forces vertically. Resolving forces vertically. Resolving forces vertically. Vertically. So our direction is vertical direction, and it is termed as y. So y is equal to, let us see, using the same concept we are going to write them. Okay, y is equal to, for the first upper triangle, it is 51 51 sine alpha. Then there is no more force vertically upward. Look at this. Only there is one force which is acting vertically upwards. Rest of the forces are acting downward. So there will be subtraction minus. For the second triangle, it is 34 sine alpha minus 34 sine alpha. Magnitude was 34. Then another one is also lying from the reference frame. It is also below this, so this is negative. Then 17 sine alpha. 17, it is not sine alpha as I have told earlier. It is, look at this, if we talk about this third one, this triangle, in this triangle, the third one here, it is not alpha, it is actually total is 180. From 180 middle portion is 90, so 90 minus alpha, that is 180 minus 90 minus alpha, that is 90 minus alpha. So it is going to be 90 minus alpha as we used in the previous case also. So 90 minus alpha. Okay, after that we are going to substitute the values, or let us expand this. So 51 minus 34, that is, from 51 if we subtract 34, that is 17. 17 sine alpha. 17 sine alpha. And you know, sorry, here I forgot to write 17 sine. So let me use the eraser. Erasing this, let me write here 17. It is 17 sine actually, because we are resolving the forces vertically. So it is 17 sine 90 minus alpha. So 90 sine 90 minus alpha is cos, you know well. So that is minus 17 minus 17 cos alpha. Now we are going to substitute the values. It is 17, and sine alpha we have got, it is 15 over 17. 15 over 17 minus 17 into cos alpha is 8 over 17. 8 over 17. So finally our resultant force is what? Our resultant force is going to be 7. So 15 minus 8, that is 7 Newton. It is 7 Newton. So the horizontal resultant force is 25 Newton and vertical resultant force is 7 Newton. Now we are going back towards our question. They told us to find what? They have told us to find the magnitude. So the magnitude is, if we draw a diagram like this, let me show. So this is our figure. In the x direction, this is x direction and it is y direction. Okay, so in the x both of them are positive. Look at this here. In the x direction the resultant force is 25, which is positive, and in the y direction also resultant force is 7, which is positive. So as both of them are positive, the magnitude will fall in the first quadrant. Okay, so this is our triangle. Let me draw the triangle a little better. Let me erase this. Okay. Then this is our triangle. This is our triangle. Okay. Now this is angle, and our vertical resultant force is how much? Vertically we have got 7 Newton, and horizontally we have got, if this is 0, so horizontally we have got how much? 25. This is 25. Now we will have to find the magnitude. Hence magnitude is equal to, we know magnitude means the length of this hypotenuse. Okay, this is magnitude, this is the magnitude. Okay, this is magnitude. Okay, so magnitude means in terms of triangle, this is hypotenuse. How can we find hypotenuse? So let us write here. I will use the left side for writing. So magnitude is equal to magnitude is equal to, how can we find this magnitude? That means this hypotenuse is equal to square root over uh, horizontal length, that is 25 square plus 7 square. So let us use our calculator for finding this. 25 square plus 7 square means square root over 625. Let us use our calculator. Okay, square root over 625. 625 right, 25.96 means 26. It is actually 26 Newton. 26 Newton if we round it up to three significant figures. So 26 Newton is the resultant force of this system. Well, now not only magnitude, they have told us to find the direction. They have told us to find even the direction. Look at this here. It is written and direction. Okay, so direction is already we have found here. Okay, this is the direction, means it is lying above positive x-axis. But how much is this angle? We'll have to know angle. So easily, as we know opposite side as well as adjacent side, we can easily apply the tan formula. So tan inverse of, and tan inverse of theta is equal to, we can write theta is equal to, sorry, let us write our angle direction. Okay, angle theta is equal to, theta is equal to tan inverse of what? Tan inverse of 7 over 25. 7 over 25. Tan inverse of 7 over 25. 7 over 25. Then we will find the value of this using our calculator. So theta, hence theta is going to be, theta is going to be tan inverse of, let us use our calculator. Tan inverse of 7 over 25. Tan inverse of, inverse of three significant figures, it is 15.6 degree. 15.6 degree. 15.6 degree. Now how to write this? We got that magnitude is 26 Newton, magnitude 26 Newton, and angle is 15.6. Where is the angle lying? Angle is lying at this point. Look, it's in the first quadrant. So how to write this? Let me change the ink to write this. We can write here for the final answer direction. For direction, if I use this tiny space, okay, direction, then you will write here direction. Direction. Direction is 15.6 degree. 15.6 degree above. Above positive, positive x-axis. Positive x-axis. Because I have already shown you that the magnitude, I mean the magnitude of the force is lying on the first quadrant. So it is above, as angle is positive 15.6, so it is lying above positive x-axis. So that's all about the solution to the question number 4. It is actually A, still B is left. So A is, what did we do? Once again, I'm just telling it in brief, that first we have resolved all of the forces horizontally, then we have got 25 Newton, then we have resolved all the forces vertically, then we have got 7 Newton. Then after this we have found, after 7 and this 25 Newton, we have just found magnitude, and magnitude is that hypotenuse of the triangle, and both x and y are lying, both x and y are positive, so they are, the magnitude will lie in the first quadrant. So magnitude is actually the length of that line, this hypotenuse, and the length of hypotenuse is the square root of horizontal, I mean adjacent square plus opposite square, and total we have got finally 26 Newton is the magnitude. And direction is, we know both vertical and horizontal length, so easily we can apply the tan formula. So theta is equal to tan inverse of 7 over 25, then we got theta is equal to 15.6 degree, and definitely it is lying, the angle is lying above the positive x-axis, means first quadrant. Well, let's see the second question. The next question is, on the next page. Okay, it says the forces of magnitude 51 Newton is replaced by a force of magnitude P Newton acting in the same directions. The resultant of the three forces now acts in the positive x direction. Look, here there is a twist actually. It says that all three forces are acting in the positive x direction. That means in y direction there is no resultant force. So we will use that concept that vertically there is no resultant force. Okay, so if we resolve the forces vertically, then we can write vertical forces. For vertically, what was our equation? We can just copy this from here. Look at this, vertical direction was what? 51 sine alpha. Instead of 51, just here we will use, instead of 51 we will use P, and rest of them will be unchanged. So y direction 51 sine alpha, P sine alpha minus 34 sine alpha. Okay, let us write P sine alpha, P sine alpha, let me change the color, P sine alpha minus 34 sine alpha, 34 sine alpha, rest of the part will remain unchanged except 51. 51 has been replaced by P sine alpha, then minus 17. Let us see what was it. Minus 17 sine 90 minus alpha. 17 sine, yes, 17 sine 90 minus alpha, and we know that 90 sine 90 minus alpha is actually cos alpha, or P of sine alpha, and we have already applied the value of sine alpha. Let us see for the last time. The sine alpha was not over here, over here. Sine alpha was this, sine alpha was what, 15 over 17, and cos alpha was 18 over 17. Okay, so we are going to apply this. Sine alpha is 15 over 17. 15 over 17 Yes, this is 15 over 17 minus 34 sine alpha is 15 over 17, same 17, and 17 into sine 90 minus alpha is actually cos alpha, and cos alpha is 8 over 17, 8 over 17. And we forgot to use the equal symbol because vertically, once again I am clarifying this. Look, this is the twist of this question. They told that horizontally there is the resultant force, whereas vertically or in y direction there is no resultant force, so it is actually zero. Resultant force is zero, there is no resultant force, that means it is balanced. So vertically there is no resultant force, but there is a resultant force in x direction. I mean horizontally there is resultant force, but vertically there is no resultant force, that's why it is actually zero. So what is it going to be? 50p into 15 over 17, 15 over 17, and in the right side it is going to be 215, so 30, 30 plus 8, so 38. It is going to be 38, or p is equal to 38 into 17 over 15. Hence our p is going to be, if we multiply 38 by 17 and divide it by 15, our P is going to be, using our calculator, 38 into 17 over 15, that is 43.06. So if we round it up to three significant figures, it is going to be 1. And that is what our P, the value of P is 43.1. So that's all about the whole of the solution. Let us see the first part of this question. Actually, in the first part, we have found the resultant force, which was 26 Newton. And if in one sentence I clarify this, first we have found the resultant force in x direction, then resultant force in y direction. After that, we found magnitude. Magnitude is square of both of the sum of the square of the both of the forces. Then the angle is actually, we have already got both x and y values or length of the horizontal and vertical axis, so we can easily apply the formula of tan inverse of 7 over 25. It is 15.6 degrees. So angle is 15.6 degree, and since both angle is positive and both x and y components are also positive, so it is lying above positive x axis. So that's all about the solutions. This is number 3. Then first part of 4. After that, final part of 4. In 4, actually, in B, there is only one twist. They have written there is a resultant force in the x direction. That means in y direction, there is no resultant force. That's why we have used equilibrium formula, that resultant force is equal to 0. And finally, we have obtained that P is equal to 43.1. That's all about this solution. We have, actually, this is very important. All the concepts are very important in mechanics. I believe that you have understood my clarification and explanation. Thank you all for being with me, and may Allah bless all of us with beneficial knowledge. Fi amanillah.